was paying attention.
Hey.
Okay,
Going
so-
this way? Going this way?
you ready? Volumes by cross sections. Okay, we're gonna start by talking about
S squared.
if this is your base, then give me the area of the region in terms of S. Okay.
Remember this.
Now, if this is your base,
With pi over 8s.
and let's go. This is an equilateral triangle, so all the angles are equal. What's the area of this? Anybody remember?
It was special.
Is it a root?
S squared.
You have right numbers, wrong places.
Root 3. Root 3 S over 2. That's what I meant.
4.
Root 3s over 4.
Duh.
Yeah.
Oh.
Come on, guys.
Oh, for the side?
Yeah.
Yeah.
Oh, root 3.
Okay, so memorize this one, root 3 over 4 side squared for an equilateral triangle.
Maybe.
Okay, we've got an isosceles right triangle. So, okay. This is supposed to be a semicircle, but I didn't know how to draw it on Word where it would cut nicely. So it really should be like right here.
Pi over 8.
Is there any way to get the area of that actual shape without doing inner?
Cutting it off, yeah. Well, it depends on where that angle is. So let's say this S is here. Okay, people remember. Pi over 8 S squared. Because for a semicircle area, you want to do it in terms of the radius, but right here you have a diameter. So since your diameter is S, you want to do pi over 8 instead of pi over 2. So just memorize this for semicircle. This is S on the base with the two sides are isosceles, but your hypotenuse is on the base. So that's 1/4 S squared. You don't really have to memorize that one too much, but if they do, give it to you. And then this is a trapezoid, so it's 1/2 times S plus KS, like the average of the bases, plus times the height, times the height. But
Oh, yeah.
the most common ones that you'll have to memorize are the square, the equilateral triangle, the semicircle, and the right triangle leg on the base. Okay, got it? All right, now we're gonna do volumes. So think about when you find the volume of a, rectangular prism. Volume is length times width times height, right? So it's the area of the base times the height, right? And if you do a triangle, like a Toblerone.
That was very good.
Thanks. It's the area of the base times the height, right? And same thing with all of these things. Like a cylinder would be, that one's terrible.
Beautiful.
Probably worst one yet. Area of the base times the height. So to find volume of anything, it's the area of the base times the height, right?
Yes.
Yeah? Good morning.
Good morning, Miss Boy.
Do you need me?
It's good
need to go home.
Okay.
Um,
I think it's recording. Okay, basically, when you find volume, you're taking the area of one cross section and you're adding it to multiple cross sections added together. So you just keep adding area of a cross section up. And if you add up all of the areas of the cross sections, then you end up getting volume, right? We can do the same thing that we did for Riemann sums, which was add up all of the areas of the rectangles to get the total area. And we can do the same thing for volume. So if we add up all of the areas of the cross sections, then we will get the volume of the cross section. So if you just remember that volume is the integral of the area of a cross section, then that's good. That's all you need to know for this section. Okay. So what we do is we start with a base, and sometimes your base you're going to do with respect to y, and sometimes you're going to do with respect to x. Okay, and then you integrate it. You find the area of a cross section, and then you integrate it, and then you'll get volume of the region. Got it?
Got it.
Got it. All right, let's do an example. So this example, this is our base right here, this region. This is y equals 1 minus x squared over 4, right? And if I want to find a cross section of this area, this is going to be, I'm going to do, oh, I didn't say. Suppose that cross sections perpendicular to the x-axis are squares. Okay. So what I'm going to do is on this area, this flat region, I'm going to pull it out, and build a square on top of the cross section. So this one, you pull the end out, and then we make a square here. Do another one down here, a little one. Okay. So if you pull those little cross sections out and then you add them all together, you end up getting volume of the region with a cross section that makes a square. If you need a visual, let's do a visual. What's my equation?
Y equals 1 minus x.
And then 0. Sections. Squares. Cross sections. Oh geez. That's not. Oh, my low is, we started 0. What's my intersection of these two? 2, right? 0 to 2. Okay. There we go. All right, so there's your cross section right here. Yes.
For second, and also these
And
two.
5th period, yes.
And sixth.
6 is in the other room, so you don't have to do 6. Okay, so this right here, in here, is this section right here. And then you built, basically you built squares on top of it, and then you make the volume of this region. The more squares you have, the more accurate your volume. So when we do the integral, we have an infinite number of squares, so it gives us exact volume of this region. Do you see it? Yes?
Yes.
Yes? Okay. Cool. All right, so we need area of one cross section. So to find the area of the cross section, remember this little length right here is your S. So remember for squares, area is side squared, right? And to figure out one side, we're going to make an equation because the side changes depending on if you're here or here. So we don't want numbers, we want equations. So the top of our square hits at 1 minus x over 4, right? And then the bottom of our square hits at 0. So this is 1 minus x over 4 minus 0. Thank you. X squared over 4 minus 0, and that whole thing is squared because that's the area. This is the length of one side. That's what S is equal to. Okay? All right, now to find volume, all you have to do is integrate this equation.
That's all you have to do.
Our cross sections start at 0, right? 0 is the start of my cross section, and then 2 was the end of my cross section. Remember, if I go further than that, it gave me that weirdo looking graph that I didn't want. Nadine, can I borrow your calculator? All right, so now we'll integrate this with the calculator. Things are going to start to get a little complicated. So if you want to, in your calculator, plug it in y1, especially if you have two equations, it's probably best. Okay. So it's in y1 now, and then I just go integral from 0 to 2 of y1 squared, right, side squared, and then dx. And your answer is 1.066. Let's fraction it. 16/15.
I know.
Okay, got it?
Yeah, I know this. I just didn't say anything.
I made it fraction, so I made it exact. I said it. Okay, let's do another one. All right, this one we have one arc of y equals sine x, so that's this is y equals sine x, and the x-axis, and then each cross section, it'll tell you what it wants it to do. Perpendicular to the x-axis means they want it to be vertical, and is an equilateral triangle sitting on the base. So all of these are little equilateral triangles sitting on here. Okay. And then if you, I don't know, you can build more little triangles if you want. Little ones. And then they add up all together. Connect them.
Beautiful.
Right. I'm getting good at drawing these. Do you need to see it?
No respect for that person.
Renee, what's up?
On the other problem, I plugged it in the same way as you, like, getting 76. I just don't know
You're getting 76?
what. 76.
Did you have this? Oops. Did you have that in? For your y
Yeah.
one?
Mm.
And did you square it?
Oh, it's x squared.
Yeah. I didn't write the x squared initially, but then I put it in, it's in here. Okay, good? All right. So we're going back to this. Cross sections from where am I going? From 0 to pi. And I'm doing equilateral triangles. Okay, so this is our solid right here. So that's our cross section. But yeah, it's like a little triangle right there.
Or a taco.
Yeah, but it's an enclosed taco. But
Like
that's
a wedge of a lemon or something.
yeah, yeah, lemon wedge.
No, not right now.
Okay, got it?
It's nice and close.
All right, so we need the area of one cross section. Remember, the base is this S right here. So area of an equilateral triangle is √3/4 side squared. And our side is going to be from the top to the bottom. So √3/4. Our top function is sine x. And our bottom function is 0 and squared. Okay? So our volume,
It's a good first step.
we just integrate it. And when you integrate, leave your coefficient out, because it's easier to do that later. We're going from 0 to pi. Those are our x values. And this is just sine x squared. So we can just do y1 is sine x. Just making sure I'm in radian mode. Okay, √3/4. Maybe I should put this in parentheses. Okay. Integral 0 to pi y1 squared dx.
Yeah. You did square root of
0.680.
4 sine. Not always on the calculator.
What's wrong, Jackson?
If it was okay, if you did.
So mine got two different answers.
Yeah, but I
The
put
top
it.
one is because it's square
Oh,
root of
because you
3
squared
over-
the √3/4. But you don't want to
You don't
square
want to because it's
the.
not-
No, yeah, that's why I said leave the coefficients out, because then you don't worry about squaring them accidentally. Okay?
680.
All right, 3 more examples of this, and then we'll be done.
680, 40 right now.
All right, so this one, the base of a solid is the region inside the circle. X squared plus y squared equals 4. That's a
Oof.
circle with radius of 2. I don't think this is gonna. Okay, find the volume of the solid if every cross section perpendicular to the x-axis is an isosceles right triangle with the hypotenuse on the base. Okay, so perpendicular to the x-axis would mean it goes like this, and then we've got isosceles right triangles here. Okay. Now, I need, so area is going to be 1/4 s squared. I need the top and the bottom of my s
What is that? My sauce is right there.
with the hypotenuse on the
Base.
base. Yeah. Okay, so I need the top and the bottom of this. So I've got to solve this equation for y equals plus or minus square root 4 minus x squared, right? So the top part is positive root 4 minus x squared, and the bottom is negative root 4 minus x squared. Okay. So you can simplify it if you want to, but I'm not going to. So the top of the S is root 4 minus x squared. The bottom is minus negative root 4 minus x squared dx. Okay, you can if you're solving this by hand, you can simplify it and then solve it by hand. If you're solving it with your calculator, you can leave it unsimplified and just plug in the positive root 4 minus x squared, the negative root 4 minus x squared. And then when you go to your home screen, 1/4 integral. Oh shoot, I need to make my volume equation. Where are we going? From -2 to 2? Of -2 to 2 of y1 minus y2 all squared. Okay. Fraction. 32/3. Cool? Any questions? All right, let's do 2 more. The base of a solid is the region bounded by y equals 1 minus x squared. Parabola shifted up 1, facing down. And y equals x to the 4th minus 1, shifted down 1, up. Where do they intersect? I think at -1 and 1. Right? But if you don't know, you set them equal to each other. Cross sections of that solid are perpendicular to the x-axis, are semicircles. Okay, perpendicular to the x-axis would be that way, and then we're doing a semicircle on top. Okay, so area of a semicircle, pi over 8 s squared. S is top minus bottom. Top curve is
1 minus x squared.
yeah. Bottom curve is x to the 4th minus 1 all squared. And then volume is pi over 8 integral. We're starting at -1 and we're going to 1. Okay, so the nice thing is if you plug them in y1, y2, you don't have to worry about all these parentheses. So 1 minus x squared, x to the 4th, minus 1. And then really I can just edit this because it's y1 minus y2. We're going from -1 to 1, and my fraction is pi over 8. Okay, so the formula is pretty much the same. I got 1.934. 1.935. People that do not like to truncate.
This is imaginary, and then this is really fun.
Cool?
Yeah.
Are you getting a good handle of this? This is
Of
the,
course.
yeah, there's just one more that we have to do. Now this one's a little bit different. This one is, the base of a solid is the region bounded by x equals 2 minus y squared. So that's a parabola shifted +2, and then the negative y squared makes it open left. And then x equals 0 is this line right here. So it's really this region that we want to, this region right here. Now this one says cross sections perpendicular to the y-axis are rectangles. So perpendicular to the y-axis means this way, with rectangles of height 3 times the base. So we've got rectangles on here that we're building, but our S is now horizontal, not vertical. Okay, so let's start with area. Area of a rectangle is base times height, but this says it has rectangles with height 3 times the base, so it's b times 3b, or 3b squared, right?
Yes.
Okay, then this is our base. I named it S, but maybe we'll name it B. And instead, since I'm going from right to left, instead of x values in here, then y values will have to go in here. So both of our equations are in x equals, which is good, that's what we want. And we, instead of doing top minus bottom, we want to go right minus left. Okay, so the right function is 2 minus y squared, and the left function is 0. Okay. And then volume, we'll leave out the 3. You can leave out the 0 if you like to. But these values right here need to be y values, not x values. So I need to know my lowest point down here, and I need to know my highest point up here. So if I set this equal to this, so plus or minus √2, right? So those are my y values. So I have a negative √2 and a positive √2 up here. And then since this is in terms of y, remember I said you can change them all into x's and plug them into y1 and y2, or you can just go integrate with the y values by choosing alpha 1 gets you a, but then just remember to square it all. And it's got to be with respect to y. Oh, you can't even see that. Okay. So 18.102. Okay. Got it?
Got it.
All right, that's cross sections. So we're not going to do any more today. We'll do discs and washers next class. And then shells the class after. And then we'll be done with this unit.